Now in question 5, this question is about projectile motion. A marble projected horizontally from the edge of the wall of 1.8 meter height with the initial velocity v here. As you can see, initial velocity is v, 1.8 meters. A series of flash photographs are taken of the marble. The photographs are combined into a single photograph as shown below. The images of the marble are superimposed on the grid that shows horizontal distance x and vertical distance y traveled by the marble. The time interval between each image is 0.10. So I'll just write down the time interval. T is 0.10 seconds. Height, as you can see, is 1.8 meters. V is the initial velocity. Now let us look at the graph. As you can see here, so distance traveled in x direction, distance traveled in y direction. As you can see, these are the points. And in between every point, the time interval is 0.1, 0.1 or 0.10, anything, 0.1. Again, 0.1 from here to here, 0.1 from here to here. Yeah. Okay. Now they're asking on the images of the marble at x is equal to 0.5 and x is equal to 1 meter. Draw the arrows to represent the horizontal and vertical velocity. Okay. So basically they're asking at this point and at this point in between, I have to show what is the vector, velocity vector along horizontal direction and vertical direction. Okay. So it has traveled 0.5 meters in x direction. So this is one vector, and in 0.5 second, 0.1 second, has traveled 0.5 meters in x direction, and from here to here, right? It is here, right? So around how much is this? So 10 boxes are 0.5. So 0.5 divided by 10. Is it 10? Yeah. 0.05. So 0.051, 2, 2 point, sorry, 0.25. 0.25 meters. Yeah. In this direction. And this is how the velocity horizontal vector would look like, and this is how velocity in vertical direction would look like. Okay. Or velocity vector at x direction, velocity vector at y direction. Okay. Okay. So they're asking on the photograph, draw a suitable line to determine the horizontal distance d from the base of the wall to the point where the marble hits the ground. Explain your reasoning. Okay. So basically, I have to find out horizontal displacement. That's it. Okay. And draw it in the graph. So main motto is to find out what is x. What is the displacement along x direction? I will show you what exactly it means. Obviously it will follow this path like this. I'll have to find out what is this x distance. I know height is this. Okay. So first of all, my first step would be finding out what is the time taken to hit the ground. Okay. Now I know height. Okay. And I know initial velocity in vertical direction, downwards, is 0. We know this. Yeah. Why? Because you can imagine a ball is in your hand and you are throwing it like in this path. So when it is in your hand, there is no motion in downwards direction. So initial velocity in vertical direction or downwards direction is zero. So I know this two information. From here, I have to find out what is the time. So you see, I can use S is equal to ut plus half at square formula to find out the time. So S is nothing but h here. U is 0. So this term becomes 0 plus half into acceleration is nothing but the gravitational acceleration g into t square. So time will be 2h by g, root 2h by g. I'll be able to find out the time, which is 2 into 1.8 divided by g is, we are supposed to take how much? Let us consider 9.81. This is what g is. They have not mentioned, right? Okay, we can take 9.1, solve it, find out the time. Root 2 into 1.8 divided by 9.81. We're going to get 0.6, 0.606 seconds. So this is the time taken for this motion, 6.606. Okay. Now you want to find out x. Okay. You see, velocity along x direction is v. Vx, let us consider, which is constant, which we can find out from the graph. And when it is covering this path in this time, it is also covering this path, this distance in x direction in the same time, t is equal to 0.606 s. So if I just multiply vx into t, since it is not accelerating, since it is constant, throughout the motion it is constant, so I don't have to consider acceleration at all. So if I want to find out the displacement, I can simply multiply velocity with time. I'll find out what is the displacement along x direction. So now I know what is the time. It is 0.606. But what about velocity? Velocity, you see, every dot, in between every dot, the time interval is 0.1. And here it has actually traveled how much distance? 0.25 actually. Oh, I made a mistake here. From here to here, when writing down the vector, it should be 0.25, not 0.5 meters. It is 0.25 meters. Okay. Or you can just ignore that thing. You can simply draw the diagram like this. That will be enough, more than enough. And draw VH and VV. That's it. Okay. Anyway, time interval is 0.1 and distance covered in x direction is 0.25 in this time interval. So you can find out in the same interval it has covered the same distance. Again, same distance is covered in the same time interval. So velocity is constant along x direction. So Vx will be 0.25 divided by 0.1, which is 0.25 divided by 0.1, 2.5 meters per second. 2.5 meters per second. Okay. 2.5 into time is equal to 0.060 into 0.6, sorry, 606 is 1.51, 1.515 meters. It has traveled. So somewhere approximately here. Okay. So if I want to draw the vector for this, I'll start from here and draw till this point, which will be dx. I can draw it here also, does not matter, dx, or I can draw it at the bottom, dx. Anything is fine. Now, a few things that we know, let us just get rid of this. We should keep this information. The next question. Use the data from the photograph to calculate the value of acceleration of free fall. Okay. Yeah. So here they're actually asking us to find out G from the graph. That's simply what they want us to find out. Okay. So what I can do is, are they using, yeah. So data from the photograph. So take 2 points. Okay. First of all, take 2 points. Yeah, I'll take this whole thing. Now the time interval from here to here, we know from every dot is created in 0.1 second. So here 0.1, 0.1, 0.1 again, 0.1 again, 0.1 again. So in total the time is 0.5 seconds from here to here to reach this point. Although the when it hits the ground, it will be somewhere here. Okay, somewhere here. No, no, not here exactly. Somewhere here, I guess. Yeah, somewhere here. Okay. Anyway, does not matter. So from to reach from this point to this point, this is the end point somewhere. Reach from this point to this point, it took time is equal to what I'll take small t. Small t is equal to 0.5 seconds. And what is the displacement in y direction? We are not considering displacement in x direction in order to find out g, because in x direction we have already considered that acceleration is ax is 0. So we cannot find out acceleration, gravitational acceleration, by considering motion in x direction. We can only find out g by considering the motion along y direction. So in y direction, what is the displacement till this point? It is around 1.25. Okay, consider this is y 1.25 meters. Okay, now we know a few things. So initially the uy, initial velocity in y direction is 0, that we know. Okay, uy is 0, we know. I'll keep do it here. Uy is 0, we know. We don't actually require this. We can get rid of this thing. Uy is 0. What is the y? Displacement in y direction till this point is 1.25. What is the time interval in this? T is equal to 0.5 seconds. Now use S is equal to ut plus half at square formula. So the acceleration acting to downwards is g. Okay. And the displacement, which is s, displacement is y, right? Y, I can write y instead of s. U we know 0. Initial velocity in y direction is 0. So it can be replaced by ui, which is eventually going to give us 0. Half, what is the acceleration downwards is g into t square. So t will be 2y by, g will be 2y by t square. Put the values 2 into 1.25 divided by t square is 0.5 whole square. All this 2 into 1.25 divided by 0.5 divided by 0.5. Yeah, it is approximately giving me 10 meters per second square. Okay, which is close to 9.81 meters per second square, obviously. So we are able to show the free fall acceleration is this 10 meter or close to 9.81. Or else there is another formula to verify this. You see, we have found out to reach the ground from here to here, time taken by 0.606, if you remember. And the displacement is 1.8. So this is the real scenario. You can use the same formula. Instead of y, you write h. So h is 1.8. U is still 0. Half g t square. Here you replace this t with big T. So you when you find out g will be 2 into 1.8, 2 into 1.8 divided by 0.606 whole square. Instead of 0.5, it is 0.606 because it's reaching this point, took 0.606. So divided by 0.606, again, 6 whole square, right? So 9.8029. So which is close to 9.81. Okay. In this method also, you can find out the free fall acceleration. So we have solved these two problems. Okay, we have solved this one, drawn the vector diagram, and the displacement is 1.5, 1.5, dx is 1.51 meters, and um this one g was approximately 10 meters per second square, or 9.8 if you can follow the method that we did at the last. Okay.